Hello students, let us come back to our MAT channel to study the concepts of mathematics from level 1 to level 12, 13, 14, whatever the grade you want to choose from the lectures what we are discussing so far. So this is a new playlist we created under the heading Elementary Number Theory. So many topics to be covered along with the problems in parts. Let us start with the first one, how to find the GCD by long division method. GCD stands for greatest common divisor. GCD stands for the greatest common divisor. So here we can take two or more positive integers, and the idea is that what is the highest factor or highest positive number that can divide the given integers. That is the idea to find out. How to find them? There are various methods are there, among which we are discussing today the long division method. Is very simple to understand for level 1 students. Let us see that how it works. Find the GCD of 1, 6 and 2, 4, 8. So I have selected two positive integers 16 and 248. How to perform this long division method to compute the GCD of those two numbers. Highest number that can divide these two. It's very simple. Always we divide the larger number by smaller number. So you can take like this 16, 248. Now we have to choose, because unlike in ordinary division, here we have to focus on 3 digits. It is not easy for a lower level student to compute that factor clearly. Let us see what is the highest number we can choose. 1 digit, it is very less than 16 here. We take 2 digits here, 24. So we can work out the 16. 16 1 times 16. So the difference is 8. Get down the 8. Ordinary division we are doing here so far. So 16 5 times it is 80. Very clear. The remainder is 8. From here, because all the 3 digits have been covered, so 16 into 15 times we are going to get 8 as remainder. This complete number by using order division. Then again, you get back the divisor that becomes dividend here. This is very simple. It goes 2 times. Once you get remainder 0, stop. So when you move along this direction, the first non-zero remainder is equal to the GCD required. We can write small letters also. Therefore, GCD, we denote like this. GCD of those two numbers 16, 248, any manner you can write. It comes out to be this one, 8. So like that we can perform based on the numbers. This procedure keep on going till you get remainder 0. Always you see that every time the remainder whatever obtained in the previous step becomes divisor, and the divisor whatever it is there the previous becomes dividend. Like that this procedure will continue till you get remainder 0. you move from down to top along this direction towards left hand direction. The first non-zero remainder, it is remainder, you see, after computing that division, it is a remainder. The first non-zero remainder is the GCD. So 8 is the highest factor that can divide these two numbers. Hope it is very clear to you. Now we are going to discuss same how to compute or find GCD by using set method. It is also one of the methods. Easy to compute GCD. Very simple. Let us take one example in our case. So for example, find the GCD, greatest common divisor, is also called as HCF, highest common factor. Both are same. For let us take two other numbers, simple numbers, 24 and 46. 24 and 46 by this method, set method. In the set method, what we will do, because divisor or factor both mean the same, just the way of writing is different. What you do, we can take let A is equal to set, means collection, set of divisors of 26, 24. We have to take all the divisors. What are the numbers that divide 24 in a set? It's very simple. In a set, we are going to use curly type of brackets. 1 will be the first number that can divide any integer, 1. Next, test which number will divide 24. 2 will divide, 3 also divide, 4, 5 won't divide, 6, 7 won't divide. You can check all those things. Very simple. 8 will divide, 9 cannot, 10 cannot. Divide in sense we should get remainder 0. Exactly divisible. 9 won't divide, 10 won't divide, 11 won't divide. Of course 12 will divide, 12 to 24. Then 13, 14, 15, 16, 17, 18. We keep on checking like that. We end up with only 24 at last. Every number is divisible by itself. I think no other number after 12 except 24 will come into picture that divides 24. Similarly, you take one more set B, you name it as B, just like same thing, set of divisors of 46. So collecting those one will be there, 2, 3, 1s are 3, 3 won't divide, 5 won't divide, 6 won't divide, 7 won't divide, 8 fails, 9 fails, 10 fails, 11 fails, 13 fails, 14, 15, 16, 17, up to 20, 21, 23. I think it divides. 23 into 2, 46. Next, no other number will divide except 46. You can cross check this too. Now, what we must to take here? We will take intersection of these two. Means we have to take those divisors which are common in this set and this set. 1 is common, 2 is common. I think only these two are only common divisors. In this set, the highest one or the greatest factor is 2. Therefore, GCD is equal to 2. The highest one, highest common factor. This is your result. or you can show GCD of 24 comma 46 comes out to be 2. But this is a very time taking procedure. We have to check all the numbers whether it divides or not. It is time consuming. Compared to 1 and 2, I recommend the first one is very simple to get the GCD. This method, it is one of the methods you should know how you can compute. For small numbers, okay, we can able to guess like this. For if the number is very huge, it is very time taking process. Only computer can generate all the divisors. So I recommend the first one when compared to this one to find compute GCD by set method. In next video, we are going to cover with an algorithm step by step procedure. That is a procedure given to computer. It can generate GCD in fraction of second, and the GCD number has more applications in number theory and cryptography, in cyber security, in higher classes level. Hope it is very clear to you this video, so that some idea you can generate what are the methods to find GCDs. It is one of them. Second one, set method we designed. We are going to see that how to apply this algorithm or procedure to compute GCD of two positive integers. So generally we can consider minimum two positive integers. The question will be like this: find the GCD, greatest common divisor, as I mentioned earlier, of 18 and 76. 762 we can take 762 by using or applying Euclidean algorithm. It is simply known as division algorithm. Both mean the same. Algorithm in sense, it is a step-by-step procedure given to a system to work out the task. Here I have taken two numbers 18 and 762. How to compute GCD by using this algorithm. So by division algorithm or this algorithm, we know that our A dividend is equal to divisor into some quotient plus remainder, so that the range of the remainder will be more than or equal to 0 and less than divisor. This indicates that dividend is equal to divisor into quotient plus remainder. It is general way to understand division algorithm or Euclidean algorithm. Now always remember that left side number should be the dividend. It will be more than divisor. Out of these two, 762. So because it's algorithm, we have to proceed like this. Step 1. We write larger number dividend 762 is equal to, I am going to use here empty brackets to make you clear how the algorithm runs. One more bracket, because A is equal to B into Q plus R. The second bracket you designate by Q1, first quotient, and the last bracket remainder 1. And this is the bracket for divisor. Out of these two, the smaller one is 18. 18. Now we have to see that what is the largest number we can take here, so that we can get a number very close to 762, not crossing this value. The excess value will be the remainder there. So by using our calculator, we can justify that very simply. I am using this scientific calculator, which is very much useful to compute GCD. In examination also it is permitted, not the application installed in our cell phone. Casio FX991 ES model. So here what I am going to do is just 762 divided by 18. I am doing 42. That is 18 into 42. It is 756 as I see here. 42 times if you multiply 18, we are going to get 756. This value we get 756. What I told you, you select a number here, a positive number, so that on multiplying these two, we are going to get a number not exceeding this dividend. So 18 into 42, we are going to get 756, very close to this one. So the leftover value is 6. 756 plus 6, we get 762. The remainder is leftover number. That is step 1. Now in next step, step 2, what is to be done? Be careful. Whatever the number you are finding before Q1, it is 18. So in this algorithm, the process is that divisor becomes the dividend, remainder becomes the divisor. That is the idea we are going to find here. Whatever the number you are finding before Q1, here it is 18. So in next step, the dividend is 18 is equal to, again you give empty bracket, 3 empty brackets, and just you see the slant position. In this position, 8 is going to come. Here, the remainder, whatever left, that is going to come. In next stage, it is second quotient, second remainder. Now it is very simple. 6 into 3, 18, no remainder, 0. Once you get remainder 0, stop. So you move from down to top direction in the remainder column. The first non-zero remainder, whatever you are going to see, that is your GCD. That is your GCD. The first non-zero remainder from down to top. Once you get remainder 0, the immediate remainder which is non-zero, which is positive, that is 6. So in 2 steps we got the result here. So we can conclude this one as the GCD of 18, 762 is equal to 6. This way, that depends on the numbers, the steps are going to increase. Next, one more example I am going to explain you, so that the number of steps will be more than 2 based on the numbers. Hope it is very clear to you. Let us see the second example, the same as how to perform GCD using the same algorithm. Let us see one more example on finding GCD by using this division algorithm. Let us consider larger numbers. Find the GCD of 276 and 86421. This time I have selected a larger numbers. Generally, such when larger numbers are there, how to compute GCD. As I told you, the same idea. I am going to highlight that division algorithm, how to remember. That is, A dividend is equal to B into Q plus R, so that the range of the remainder will be from 0 less than B. It can take 0 up to a value less than B. B is a divisor. So step 1, larger number is 8, 6, 4, 2, 1. As I told you, give 2 empty brackets with product sign plus 1 more bracket for remainder. Let us indicate this one as Q1, first quotient, first remainder. The divisor is 276. Now what I told you, we first you take a calculator, it will save time instead of doing manually. So what I will do, first what number you have to take here, so that we get a close number to this value 86421. So what you must do, 86421, if you divide by that value 276, it is going to give you 313 approximately with some value. So I'll write here 313. Now if you multiply these two, First step is very crucial. You take 313 into 276. We got a value close to the 8638. You see very close to this value. If you subtract this value from the original value on left hand side 86421, we are going to get remainder as 33. If you subtract this value from this, we are going to get the remainder value 33. In step 2, what is to be done? Same. In place of dividend, this divisor come into picture 276, the number before Q1. Again, you take a product of two brackets. Here also one bracket for remainder. It is Q2, it is R2, second remainder. In place of divisor, the remainder going to come into same idea. We have to take a number here very close to 276 such that we are going to get remainder again. So what is to be done? Take 276, just divide using calculator 33. It is showing a whole number 8 times roughly. 8. If you multiply these two, what you are going to get? That is 8 times 33. It is 264. You can check through calculator. Difference of these two is a remainder. Minus 276. We are going to get the remainder 12. Be careful with the values. Step 3. Again same. Before Q2, 33 is a new dividend. It is Q3, third quotient, third remainder. Here we get 12. 12 how many times will go? 12 to 24. 12 36, it exceeds. 12 2 times it is 24. 33 minus 24, 9. Step 4, still it goes on. Here 12, number before Q3, R4, Q4. Here the number before Q3, 9. Here we get in place of this 9. Obviously only one time, 9 ones 9. 12 minus 9 is 3 the remainder. Step 5, here 9, here we get 3, it is R5, Q5, 3 times will go exactly, remainder 0, stop. Once you get remainder 0, stop, you move from down to top direction, the first non-zero remainder, whatever it is there, above 0, that is your GCD of those two numbers. So what is the conclusion? Therefore, our GCD of the given numbers 276 and 86421 must be 3. So 3 is the highest number that can divide both of these two numbers. Hope this example is clear to you all. Like that, any numbers if it is given to you, you can compute GCD by taking 2 the same manner. Next, how to express GCD as a linear combination of two integers given to you. A special type of topic called how to express the GCD of given two positive integers. Here I am naming it as small a and small b. Two positive integers they are going to give you, and we are going to find out GCD first, as I mentioned earlier, by using that algorithm, Dewey algorithm or Euclidean algorithm. This word, the linear combination of the given two numbers. For example, very simple. Here two parts will be there. In first stage, what we will do, if GCD of AB, A comma B, if it is D, some value we got D, then what we are going to do, this D, the GCD whatever obtained, we can write linear combination of A and B, means A into some integer plus B into some integer. Here we can write separately where x comma y belongs to set of integers. It is a unique way to write. So GCD can be expressed in the form of the equation a into some integer plus b into some integer. This equation is also known as Diophantine equation. Diophantine, name of the mathematician, Diophantine equation in two variables. In two variables. It is additional information there. It is given to Diophantine. So how to express the GCD as a linear combination of the given integers a and b. Here x and y are unique integers. We are going to find out what value of x and what value of y are multiplying these two. We get back GCD. It is also called as Diophantine equation in two variables in x and y. Here the variables in sense here x and y we are going to find out in general. That method we are going to discuss using a problem, and it is very important and has many applications in cryptography. In number theory, this approach is very important, expressing the GCD as a linear combination of the given positive integers c and b. Let us discuss by taking a numerical example so that you can able to understand very clearly. So let us see how it works with the help of an example. So let us take a question how they are going to ask in examination generally. They will ask you like this: express 176 and 2941 as like this: 176 into x plus 2941 into y, which is equal to the GCD of the numbers whatever you have taken there, 176 comma 2941, where x comma y belongs to set of integers. Now we are going to find out x and y as unique integers so that we can able to express the GCD of these two like this. This you can write either way. You can take 2941 into x plus 176y also. These two numbers we can write any manner we like. Here we can write 2941 into x plus 176y also, because GCD of two numbers you can interchange, the value won't change, the GCD won't change. Here the problem will run in two parts. First we have to find out the GCD as I mentioned earlier, how to work out. So part 1, in part 1 find the GCD, the given numbers 176 comma 2941 by that algorithm already mentioned, Euclidean algorithm. So here I am not going to write down step 1, step 2, step 3, step 4, already it is done. Directly I am going to attack on the problem. The larger number is 2941. This is the dividend. Divisor is 176, and I am going to give you the brackets here for Q1 and R1. So using calculator we can express how many times it goes. 176 2941. It's very simple. I told you take 2941 roughly we divide by 176. It is showing here 16, whole number 16. So yes, 16 times roughly it will go, not exactly. So to get the number 16 times 176 comes out to be 2816. The product of these two, difference of these two, we get 2941, we get 125 as remainder in first stage. Next, the number before Q1 is 176, that becomes the dividend here. In place of divisor, the remainder will come and sit. This is your second quotient and second remainder to be obtained. 125, obviously only one time, this value is 125. So difference 6 minus 5 1, 7 minus 2 it is 51. Third stage, the number before Q2 it is 125. Here we get the remainder 51. Third quotient, third remainder. 2 times, what do you get? 2 ones are 2, 1 are 2. So difference 5 minus 2, it is 3, 2. Next stage, we get 51. Here we get 23. It is Q4 to be obtained, R4 to be obtained. 23 twos are 46. Difference is 5. I continue here. 23. Here we get 5. R5 it is Q5. 5 fours are 23 is the remainder. Next stage 5 comes. This one. Here 3. 3 ones are 3. 2. Next 3 is equal to here 2 into 1 plus 1. Q7 R7. Last 2 is equal to 1 into 2 plus 0 star R8 Q8. So the first non-zero remainder above 0 is 1. So the GCD of these two numbers, whatever I considered here, 176 comma 2941 equal to 1. This is your D. And remember, whenever you get GCD value is 1, these two positive integers are called co-primes. So these two are called here, because GCD value is 1, here 176 and 2941 are called co-primes. Remember this note tag. Whenever you get GCD values 1, the numbers are called co-primes. So part 1, we have to find the GCD by using division algorithm, as I mentioned earlier. Total 7 steps we got. So GCD is 1 because the last non-zero remainder is 1. The next part, how to express this 1 or D as a linear combination of these two numbers. That is a part 2 thing we are going to do it. Let us continue next part, how to find out the x and y values. Let us continue the problem of part 2. Part 1, I found out the GCD of these two numbers 176 and 2941 by using division algorithm. So I took only that steps, 8 steps we obtained, step 1, step 2, step 3, 7, step 8. Once you get 0 remainder, we have to stop the procedure. So we got the first non-zero remainder is 1, D. Now we have to express this 1 which is equal to D here as linear combination of 176 and 2941, where x and y are integers. What is to be done? You have to be careful on remainders. What you do? Isolate the remainders. Isolate means separate. Isolate the remainders. You move from top to down. First remainder is 125. So I write 125 is equal to, bring this term that side. So what do you get here? 2941 minus 176. Of course, brackets are there. You maintain same thing, no change. You name it as first equation. Similarly, separate remainder 2, 51 here. 51 becomes, bring this term that side. So we get 176 minus, we get 125 into 1. You write as this, it is second. Third remainder is 23, we are separating. Bring this term that side, we get here 125 minus 51 into 2. Name it as third equation. Next come to remainder 4, your 5 is there. Separate that, 5 is equal to, bring this term that side, we get 51 minus 23 into 2. It is fourth equation. You just name them. Now next remainder is 3, we separated. Bring this to the other side, we get 23 minus 5 into 4. It is fifth equation. Next remainder is 2. Separate 2. 2 equal to 5 minus 3 into 1. It is sixth equation. Last remainder is 1. 3 minus 2 into 1. It is seventh equation. The last one remainder 0. It is not required. You can't take this. So what is to be done? Just separate the remainders or isolate the remainders like this and name each equation by a number 1, 2, 3, 4, 5, 6 like that. Now what is to be done? Apply backward substitution method. That is, we have to move from down to top using this backward substitution method. This we discuss how to substitute because it is a long type question. First part is finding GCD using division algorithm, then separating the remainders like this, and third part is we have to use backward substitution method to get back this form. Now down to top or backward substitution method, first you have to take equation 7. Consider equation 7. What is it? 1, 1. From down to top, 1 is equal to 3 minus, just take asterisk, 2 into 1. Now once it is considered, you put a cross mark here, the step is over, that equation is done. Now what you do, you check next remainder above 1, it is 2. See 2 with this side, here 2 is there. Where this 2 is present? Here. So here we have to replace this 2. Just give arrow like this. Replace it from which equation? It is in sixth equation, from sixth equation. So what is to be done? We have to substitute only 2 there. Don't write anything on left hand side. Is equal to 3 minus, here in 2 I am going to write down what is the expression for 2 here. It is 5 minus 3 into 1, of course into 1, this one. Now don't disturb, don't do anything unless and until you see the remainder. This is done now. Put a cross mark there. 2 is substituted. Don't disturb. You see above remainder is 3. You should not disturb 3. There is idea here. So 3 is there. Don't disturb it. So we can write it as 1 into 3 or keep 3 as it is. 1 into 3 minus 1 into 5 minus plus 1 into 3. I am not multiplying, just I am applying the property. This 3 I wrote 1 into 3, 1 into minus 5 minus 1 into 5 minus plus 1 into 3. Now just you have to combine these two. 1 into 3 plus 1 into 3, we get 2 times 3. 2 times 3. And this one as 1 into 5 as this. And now what I will do, because our next remainder is 3, I can write this one as 2 into 3, just brackets are interchanged, minus 1 into 5. Just I change the brackets. Now this 2 is replaced, next is 3. Where is 3? Here 3 is there. Here we need to replace. Now we need to replace 3. Replace. Check only the remainders. Replace it from which equation? Equation 5. I think so, 5. So we are going to get is equal to 2 into, for 3 we have 23 minus 5 into 4 as it is. We replaced minus 1 into 5 as it is. You see the next equation, 5 is the remainder, should not disturb 5. So what we must do? These numbers should not disturb. Keep in mind, whatever the remainders are there should not be disturbed or multiplied. Now 23 is also important here, so no need to disturb. 2, this we can write as I'll continue with this 1 equal to the same continuation. So we can write 2 into 23. Don't multiply because it is there on left hand side. Next 2 into minus, if 5 is not disturbed, should not be disturbed there. 2 into 4, it is minus 8 times 5, and last one 1 into 5. Here 23 and 5 should not be disturbed. So here 2 into 23 as it is, minus 8 minus 1, it is minus 9 times 5. 9 times, just you treat 5 as x there, minus 8x minus 1x, it is equal to minus 9x. Just have to combine the terms. Now we have to replace next remainder 5 because equation 5 is done. Now we have to replace 5. Here 5 is there. Replace it from equation 4. Equation 4. So what you get here? 2 into 23 as it is, minus 9 as it is. For 5, you have to substitute complete this expression. 51 minus 2 into 23 as it is there in 4. Now here 23 is important and 51 is important. Next remainder. These are remainders which are there on left hand side, should not be disturbed. Disturbed means you should not multiply with the numbers. You keep them as it is. So 2 into 23 as it is, no change. 51 is also required, no disturb. So minus 9 into 51 as it is. 23 should not disturb. So 9 into 2, it is plus 18. 18 times 23. Now combine these two. Times 23 plus 18 times 23 gives you 20 times 23 minus 9 times 51. Now we have to replace next 23. It is here. So don't disturb the remainders on left hand side. This we have to replace now. Replace it from equation 3. Equation 3. So what is to be done? I can now I'm going to replace 23 in place of this number from equation 3. So that is equal to 20 in place of 23. The complete expression you have to write down there. 125 minus 51 times 2. This one will be as this 9 times 51. Hope it is clear to you. Now what is the thing? We should not, now left side 51 is there, 125 is there. 51 and 125 should not disturb them. Should not disturb them. Just remaining terms you can have to multiply. So 125 is required. So 20 times 125, keep in bracket. 51 also important, should not be disturbed there. 20 into 2, it is minus 40. 40 times 51. This one 51 is still there, keep like that. So I replaced. Next one we need to replace 51. So combine these two, what you get? 120 into 125, only one number. Minus 40 minus 9 minus 49 times 51. 51 will replace now. Now we have to replace 51 here. 51. So I am going to write down these two equations. You see in the previous we have to replace 51 by the help of equation 2. 51 is equal to 176 minus 125 times 1. In place of 51, this is the thing I replaced. Now this part is not required. Now let us continue. 1 on left hand side is equal to Our next equation is 125. Should not disturb 125 and 176 because equation 2 we are replaced now. 176 should not be replaced. 51 and 125 are very crucial. So we get here 20 as this into 125. There is no change here. Minus 49 times 176 minus minus plus 49 times 125. Now these two we can combine. 20 plus 49 is 69 times 125 minus 49 times 176. Now we need to replace by using equation 1 125. You can see on left hand side this is the last remainder to be replaced. Replace it from equation 1, last stage, equation 1. So what you get here 69 as this into what is 125? It is equal to 2941 minus 176 into 16, first equation, close, minus 49 times 176 as it is. Now we should not disturb the main numbers. Main numbers are 2941 and 176. So 69 into 2941, I wrote like this, minus 16 into 69 because 176 you should not disturb. This is the main number. So using calculator, if I multiply those two, 69 into 16, it is 1104. 1104 times 176. This one of course as it is 176. Now we can combine these two. 69 times 2941 minus 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 1104. 4 plus 9 13 5 1153 times 176. Therefore, we can write this GCD 1 is equal to, we can write minus 1153. First I wrote plus 69 times 2941. You see in place of here x is what? X equal to 1 minus 1153 and our y value is 69. We express GCD 1 is equal to minus 1153 into first number plus 69 into second number. This is called linear combination of x and y. Here x value is equal to minus 1153 and y is equal to 69 because I gave you 1 should be equal to 176x plus 2941 into y. How to test your answer is correct or not? Just simplify this, you should get 1. You are going to get 1 here. Multiply these two and subtract this number, you are going to get 1. We get here 69 into 2941 minus 176 into 1153. We get 1. Verify. This is a way to test your answer is correct or not because everyone should get a unique x value, unique y value. The last step is your confirmation step. So your GCD is 1. So 1 can be expressed as minus 1153 into x. It is x value. 176 into x plus 294 into y. Y is 69 value. Is a way to express the given GCD. In place of x we got integer minus 1153. In place of y we got 69. So this is the method how to express the given GCD as a linear combination of the given integers. So you are going to get the unique integers x and y. The way you write is different. You can write like this way also. Then we can write x value is minus, so x value is 69 and y is minus 1153 as the case may be. Here he gave like this. So first part is you have to compute the GCD of the given two numbers by using division algorithm very systematically. Next part, separate the remainders, name the equations, then apply backward substitution method from down to top, replacing the remainders and the main numbers. Don't disturb the main numbers and the left hand side, whatever you are going to separate remainders. That care you must take out and keep on replacing, adjusting the coefficients and combining the terms. We get unique values for x and y like this. Prime number test. So prime number in sense the numbers which can be divisible by themselves and 1, because 1 will divide every number. So simply to remember, the numbers which are divisible by themselves are known as prime numbers. For example, 2, 3, 5, 7, we can list out them. There is an end for that. In our next coming topics, we are going to use this prime factorization method. A stage comes where the student is not able to proceed further, whether it is a prime number or not. So to decide that number or to check that particular number is a prime number or not, a small test is readily available that we discussed today. So these are steps we followed. These steps we have to follow to test the given number is a prime number. Step 1, identify two consecutive squares so that the given number, I will write positive number here. We discuss only positive primes. The given positive number, let us say small n, or you can take small p. Better we choose small n, will lie between them. Step 2, take square root for each number. I'll explain about the second step with an example, then it becomes very clear to you. Step 3, list out all the prime numbers that are less than or equal to the first square root number. Step 4, the last step, if no prime number divides n, then we say that n is a prime number. So these are steps to be followed to test the given number n is a prime number or not. These 4 steps will help you to decide the number given to you is a prime number or a composite number. In next video clip, I am going to give an example based on these 4 steps to decide the given number is a prime number or not. So these 4 steps you should know very clearly, memorize them so that we apply these 4 steps to fix our conclusion regarding prime numbers. Hope this information is clear to you regarding prime number test. We are going to apply those 4 steps now to check this number 41 is a prime number or not. How to work out this? Very simple. First step says that choose 2 squares so that this number will lie between those two. Clearly 5 square is 25, less than 41. Next 6 square 36, less than 41. 7 square is 49, it exceeds 41. So 36, that is equal to 6 square. Immediate the consecutive means after 6 we get 7 I write 7 square here. It is 49. Clearly, between these two, our number 41 will be lying between. 41 lies between these two consecutive squares. Here, we can say that n equal to 41 for time being. Our n is equal to 41 lies between these two squares, consecutive squares. It is step 1, as I mentioned in the previous video. Step 2 says take square root of each number. Square root of 36, obviously less than square root of 41, less than square root of 49. The value of root of 36 nothing but only 6 we get. You leave this as it is, no need to simplify, and this will be 7. This will be 7. Now what you must do in third step? In third step, check the first number. Clearly it is a composite number. It is not a prime number. So in step 3, we have to list out all primes less than or equal to this number, first number. It is first square root number, as I mentioned in the step, square root number. It is not required, right? First square root number. I am going to list out all the primes, means prime numbers, primes less than, because 6 is a composite number, only less than. If it is a prime number, less than or equal to, must mention there, less than 6. So what you get here? 2 is a first prime number, less than 6. 3 is a prime number, less than 6. 5 is a prime number, less than 6. Next will be 7, should stop. So we got 2, 3, 5 prime numbers which are less than the first square root number. Step 4, in step 4, see, 2, we write a symbol for divides. If you write vertical line, it is called divides. If I write like this, does not divide. 2 does not divide 41 because it leaves some remainder 1, right? Similarly, 3 also does not divide 41 and 5 also does not divide 41. Fourth step says all these prime numbers should not divide the given number. If no prime number divides the given number, then this is a prime number. If any one of them divides, it is called a composite number. It's called a composite number. Therefore, 41 is a prime. Why prime? Because these three prime numbers are not dividing 41. If any one of these divides 41, then 41 is not a prime, it is a composite number. So this is a simple test to decide whether the given number is a prime number or not. We can remember the test name as square root test for easy to identify. Square root test. Square root test. You can remember this word to apply the 4-step mechanism to decide 41. I will give one more example so that we can apply the same thing to decide whether it is a prime number or a composite number, so that you get the clarity about the protocol or the 4-step mechanism to apply for checking a number is a prime number or a composite number. Let us continue other example to test whether given positive integer is a prime number or a composite number. Now here I took one more number, 137. We apply that 4-step mechanism to decide whether it is a prime number or a composite number, a similar manner. So first step is that we have to choose two consecutive squares so that this number will be lying in between them. So for timing, you can choose let n is equal to 137. 137. Now closest the square which is less than this one is 10 square is 100, 11 square 121, 12 square 144. It exceeds. So 11 square, that is equal to 121, and next immediate consecutive number is 12 square, that is equal to 144. You see this number 137 lies in between these two squares. Step 1. Step 2 says we have to take square root for these numbers, that I am writing as it is. It is very simple. 11 is a square root for this one. You can leave this one as it is. This is step 3 says, so you see 11 is a prime number here. The first square root number, this is the first square root number is a prime. 11 is a prime. When that is a prime, then what we have to do in step 3, we have to list out all primes, means prime numbers less than, or because we got 11 is a prime here, or equal to, this you must write, equal to 11. If it is a composite number, no need to write or equal to, only less than that number. Clearly what you get here, 2 will come, less than 11, 3, 5, 7, next is 11. Next is 11. Because I told less than or equal to 11. Step 4, we need to check the divisibility. 2 does not divide 137. What about next? 3, 3 4s are 12. It won't divide. 3 also won't divide. Next, 5 also won't divide. You can check this. It leaves some remainder. 7, 7 1 is 7, 6. It won't divide. What about 11? 11 ones are 11. It also won't divide 137. So no prime number is dividing this 137. All these prime numbers were 2, 3, 5, 7, 11. So what is the conclusion? That is a prime number. Therefore, n equal to 137 is a prime. If any one of the prime numbers divides the given number, then it is called a composite number. Be careful. No prime number should divide that number. In the step 4, then only we can say the given number is a prime number. Hope you followed the test, how to apply to decide the given prime number. Given number is a prime number or a composite number. Last step will decide. If any one of the primes divides the given number, it is a composite number. Divides any one. One, at least one. Two prime numbers also may divide. It depends on the problem. Here you see, no prime number is dividing that given number 137. That's why 137 is a prime number. Important theorem called fundamental theorem on arithmetic or fundamental theorem of arithmetic. That is very widely used to compute GCD and LCM using that method. To discuss about fundamental theorem of arithmetic, and this is widely used to find out GCD and also LCM, least common multiple, for a given two numbers by expressing the given numbers in prime factorization form. Separate method is there to compute LCM and GCD. In coming videos, we can discuss that. So, what actually the theorem states? Is it simple? Only one line. Every positive integer n, of course, it is more than one. Every positive integer n can be expressed. We can written as, I'll show in symbols so that you can able to understand here. N is a given positive integer which is more than 1, value is more than 1. That n we can write like this. P1, I'm giving brackets, 1 power alpha 1 into P2, its power is alpha 2, P3, its power alpha 3. It goes on up to certain stage up to k, alpha k, where here P1, P2, P3 up to Pk are different primes. Primes means prime numbers. And I wrote alpha 1, alpha 2, alpha 3, alpha k are the corresponding exponents. Exponents means powers. It is also called powers of different primes. What is the meaning of this one? P1, P2, P3 up to certain stage Pk, they are different primes or distinct primes. Alpha 1, alpha 2, alpha 3 up to alpha k are the corresponding, means alpha 1 is the power of P1, alpha 2 is the power of P2, alpha 3 is the power of P3. Like that, alpha k is the power of Pk. Exponents or primes both are same of these different prime numbers. Here prime number P1 appearing alpha 1 times, P2 appearing alpha 2 times. That's the meaning of this one. Any positive integer you take, we can write like this, like a train of or a product of distinct prime powers. In shorthand notation, we can write that n value very simply like this. Instead of writing like a chain of products, we can write, when you multiply every term successively, we use this capital pi notation and we write index I ranging from 1 to k. We write here Pi's index I alpha I. What is the meaning of this one? If I take I equal to 1, we get the first one. Pi is for product, we have to multiply them into, next take 2, next 3. So this complete product of prime powers we can show in short form like this. In next video, I'll give some examples based on this fundamental theorem of arithmetic, how you are going to express a given positive integer as prime powers. This technique we are going to use to find out GCD and LCM. This technique we are going to apply to find GCD and prime and LCM for a given two positive integers or more than two also. Thing is that we have to express the integer like this as prime powers. Let us see one example on that so you get the idea how to express the given positive integer as product of prime powers, different prime powers. So every day you are going to get a new concept to learn in mathematics. If you understand concepts, so in any examination you can apply those concepts to score marks. We are going to apply that theorem to these three numbers: express 148, 296, 46, whatever it may be, right, as a product of distinct prime powers. If this sentence is there, we are applying here fundamental theorem of arithmetic. Both are same. So first, let to suppose our n is equal to 148. Clearly, it is more than 1. It is more than 1 as per our condition. Now, what you do, you have to divide, try to divide, if possible to try to divide that 148 only using prime numbers 2, 3, 5, 7 like that. You should not take a composite number to divide. That is the difference. That is the main role to be played here. For example, 148, you draw a line. Because 8 is there, obviously we can divide that number by 2. So take the 2 is a prime number, 2 sevens are 14, 2 fours are 8. Again, it can be divided by 2. 2 is a prime number, 2 3 are 6, 1 remainder, 2 sevens are 14. Now you see, in the previous videos, one of the videos I explained how to test a given number is a prime number or not. Here you got 37. Whether to proceed, and don't waste your time which number will divide, because 2 won't divide, 3 won't divide, 5 won't divide like that. That if it is a prime number, that number will be your the next prime, it divides 1. You can check by the test. 37 is a prime number. Here I will show 37 will lie between 36 and 49. It is 6 square, it is 7 square. 7 square, as I explained earlier. You can decide. Once you get a number there, don't waste your time whether we have to proceed further or not. You can decide, check whether that number, whatever you obtained here, is a prime number or not. If it's a prime number, the same number will divide. Otherwise, you can move further with other prime number 3, 5, 7, 11 like that. Here we got 37. We pause that process and we're checking here. Then square root of 36, square root of 37, just idea sake I'm giving here. We get here 6 less than root 37 less than 7. And 6 is a composite number, 2, 3, 5. Clearly 2 won't divide 37, 3 won't divide 37, 5 won't divide 37. That's why it's a prime number. So we can stop at this stage. Stop at this stage. When you get a number, better check whether it is a prime number or not. If it is a prime number, then same prime number will divide that number. If it is not a prime number, we can move further. So once you get last value as 1, you stop the process. Stop this process of division. Now how you write? Therefore, our n, which is equal to 148, we can write, what are prime numbers we got here? 2 is the prime number, in bracket 2. How many times we are getting 2? 2 times. Into 37 x prime number, it appears only 1 time. So it is P1 here. What is P1? P1, first prime is 2, its power is, second prime number is 37, its power is 1. Like that. We expressed 140 as 2 square into 37 power 1. What about second one? 296. Same procedure. Try with 2, 2 ones, 2 fours, 2 eights. Again, with 2 it will go 2 sevens, 2 fours. Again with 2, 2 threes, 2 sevens. Same. 37 we got here, 37 times 1. Therefore, how you write 296? 296 is equal to 2 power 3 because 2 appears 3 times, 37 power 1. Like that. Third one is very simple. 46 is here. It will go with 2, 2, 3. 23 is a prime number, as I guess, times 1. Therefore, we can write 46 equal to 2 power 1 into 23 power 1. Like that, you have to divide only using prime numbers. If you get any number, you have a doubt, just check whether it is a prime number or not like this. Then you can stop by dividing that prime number the same number. Once you get 1, you stop the process and you can express like this. It is called application of the fundamental theorem of arithmetic. Any positive integer we can express like this, product of prime powers. And this idea we are going to use to find LCM and GCD in next coming videos. Hope this example is clear to you how to express a given positive integer more than 1 as a product of prime powers. Nothing but application of fundamental theorem of arithmetic. So we are going to use this fundamental theorem of arithmetic to find out GCD and LCM for given numbers. Minimum 2 or 3 or 4 like that. Now we are going to work out based on this to find GCD as well as LCM. We are going to discuss how to compute GCD or how to find the GCD of given 2 or more positive integers by using prime factorization method. Nothing but application of our fundamental theorem of arithmetic as we discussed in the previous video. So how we have to work out this process to obtain GCD of these two numbers? First, you suppose that n equal to 64 and you can choose different letters also as per your wish. Clearly, they are more than one, because we have to apply fundamental theorem of arithmetic. Now we have to apply which one? The fundamental theorem of arithmetic. This already discussed in the previous video. So first 64 prime factorization. First prime number is 2, so take 2. Again it goes with 2, again with 2, again with 2, again with 2, 2. Only 2s it will go. Know the prime. So how you write n? N is equal to, we got 64, that is equal to 2 power 1, 2, 3, 4, 5, 6. So better write down here at the bottom P1 equal to 2, only one prime number, and alpha 1 its power is 6. Next you take 78. First prime number is 2, 2 3 is 6, 2 9 is 18. We can check with 3, I think so. Next prime number 2, it is not possible. With 3 13s. Of course 13 is a prime number, we can stop by taking the same number. So here what you get? Therefore our m that is equal to 78, we can write as 2 is a prime number, appears one time, into 3 is one more prime number, appears one time, and 13 is one more prime number, appears only one time. So here we can write, for idea's sake, P1 is 2, alpha 1 is 1, P2 is 3, alpha 2 is 1, P3 is 13, alpha 3 is 1. First step is that we have to find out the prime factors for n and m like this. Next, GCD, how to compute GCD of the given number 64 and 78 is given by You choose because greatest common divisor. Common means the prime number should be present in n as well as in m. What is the prime number that is common in n and m? I think only 2. 2 power 6 here, 2 power 1. That's the only one prime number common in these two numbers. You take that prime number 2. And power you must write down. Min stands for minimum, and you give a set bracket here. What are the powers of 2? 1, there it is 6. You have to collect all the powers in that set. Before the set you write minimum, min. What is the meaning of this? We have to take 2 as this. Out of these two numbers, what is the minimum number? It is 1. So 2 power 1 is 2. This is your GCD. This is your GCD. So to find out GCD of any numbers, you find, suppose 3 numbers are given to you. Same like this, you perform M, N, Q like that. In finding GCD, you pick up what is the common prime number that is present in all the numbers. Here 2 is the prime number, can be seen in both. So you take that prime number. Suppose one more prime number is there into that prime number. What power you have to take for that common prime number you selected? You write minimum and list out all the powers of 2. Here 1 is the power, here 6 is the power. Out of 1 and 6, the minimum power is 1. So 2 power 1 is 2. That is a GCD of 64 and 78. Is it clear to you? So like that, we have to find out GCD for any set of numbers given to you using fundamental theorem of arithmetic. Now in this lecture, how to compute LCM, least common multiple of two or more positive integers by using prime factorization method. In the previous video, we discussed how to find GCD, greatest common divisor, or HCF, highest common factor, for two or more. Any number of positive integers more than one, if they given to you, we can apply that fundamental theorem of arithmetic, expressing each number as prime powers, distinct prime powers. Then we have to, for finding GCD, we have to take all the common prime numbers present in the given numbers first stage in the product form. Then for each prime number, you take the least power among all those powers finding in each number. That is the GCD one. Here what is to be done? So same procedure. Let you name them as n equal to 96, that is more than 1, and m value 196, that is also more than 1. First we need to express these two numbers as product of different prime numbers. For 96, it is very simple. It goes with 2. 2 4 times 2 eights. Again 2 we can divide 24 times. Again with 2 it will go 12 times. Again with 2 6 times. Again with 2 3 times. Now next prime number is 3, only one time. Stop. So therefore, how you write n? N equal to 96. Prime number 2 is available here. It appears 1, 2, 3, 4, 5 times into 3 is next prime number, appears only one time. No need to mention P1, P2, alpha 1, alpha 2, it is understood. Next, I'll take that is 196. 196. With 2, you can try 2 9s 18, 2 8 16. Again with 2, it will go 4 times, 9 times. 3 won't go. That 7 we can take. 5 won't go. 7 7s 49. 7 ones. That's all. So how you write 196? That is equal to 2 is a prime number. It appears 2 times into 7 is a prime number. It appears 2 times. So we expressed 196 and 96 as prime powers. Now, how to compute GCD LCM here? LCM of 96 and 196. In GCD, we have to take common prime numbers in N and M, but here, what are the prime numbers you are going to see that you have to collect? All prime numbers you must write. Simply to say, we have to take all the prime numbers. 2 is a prime number. First I write 2. 2. There you write max. That bracket. What are the powers of 2 available here? 2. There 5. Into. Next prime number is 3. Bracket. Again write max. What are the powers of 3 available to here? Only 1. Only 1 here. Into. Next prime number is 7. Same procedure, write max. I think the power of 7 is only 2 here. Only here it appears. Power is 2. Now, based on this information, we have to take 2. Max means maximum. Maximum of 2 and 5 is 5 into. Next one is 3. Maximum of 1 is only 1. Here also, maximum of 2 is only 2. So this we have to multiply and compute. 2 to the power 5, it is 32, it is 3, it is 49. Let us use calculator and compute. 32 into 3 into 49. It is 4704. 4704. You can use calculator. 4704. That is your LCM. Least common multiple. Least common multiple. And this is a way to work out LCM and GCD. Be careful. In GCD, we have to take common prime only and take the least power, minimum power of that prime number. In LCM, we take all the prime numbers. Powers must be the maximum power what the prime number attains in all of them. In all of them. That we have to choose. After that, compute the product carefully using calculator. We get the LCM as 4704 for these two numbers. If you want to find out the GCD, it is only 2 power 2, that is 4. Because 2 is the only common prime number and least power of 2 is 2. 2 power 2 is, it is additional information. I write here. If I write here GCD, if you want to compute for those two numbers, as I mentioned in the previous video, that is equal to common prime number is only 2. Here we write minimum. What are the powers of 2? It is 2 and 5. So we have to take 2. Minimum power is 2. That is 4. 4 is a GCD. 4 is a GCD and LCM is 4704. Always LCM value will be bigger than GCD value. Hope this video is clear to you. To find out the LCM and GCD in two separate videos I explained by using that prime factorization method. It is also called as fundamental theorem of arithmetic, how to apply it. In next video, we are going to see how to find number of divisors for a given integer, positive integer, and how to find their total. And one more video, how many positive integers are there less than that given positive integer which are prime to it, relative prime to it. So 3 more videos to come based on that, and later we come to know a new topic called congruences. Do share and subscribe our channel with your friends so that learning will help you a lot through these lectures. Thank you.